Let's have a look at question 7 now. So for this test we're going to use a significance level of 0.05. Now if the true mean is in fact 1100 liters, then the power of this test is going to be 0.12. Let's see. So recall, we did a question about power a couple of videos ago. We're going to use the same method. First of all, we have to find out what are the sample means that allow us to reject the null hypothesis, and then based on this true mean of 1100 liters, we're going to see what is the probability of being able to reject that null hypothesis. So we will reject the null hypothesis if we will reject H0 if our Z values are going to exceed the critical values. So the Z value has to be greater than or equal to the critical value at the significance level of 0.05. Well, 0.05 belongs to two sides, meaning we're going to have 0.025 on one tail. The Z value corresponding to that is going to be equal to 1.96. And the reason we have it on two sides is because the test that we're doing is two-sided. So Z must be greater than or equal to 1.96, and on the at the same time, Z must be less than or equal to minus 1.96, since the rejection region can occur in either of these places. So what is the Z value? The Z value is a standardized value, so it's the difference between the sample mean that we're interested in from the mean of the population under the null hypothesis, from 1000, divided by the standard error. And recall the standard error, we have it over here, that's equal to 400 divided by square root of n, sigma divided by square root of n. So we have divided by 400 over square root of n must be greater than or equal to 1.96. This must be greater than or equal to 1.96. Let's solve the math. We multiply this term with that one and add 1000 to it. So we're doing a cross multiplication over here. X bar, the sample mean, must be greater than or equal to X bar must be greater than or equal to 1261.33. That's one option to reject the null hypothesis, and the other one is by replicating the same logic over here right next to it. We're gonna standardize this Z value in the same manner, so X bar minus 1000 divided by the standard error of 400 divided by square root of n must be less than or equal to the other critical value on the left side, so must be less than or equal to minus 1.96. Same thing, multiplying this term with minus 1.96 and adding 1000 to it over there. So X bar is going to be less than or equal to, X bar is less than or equal to 738.67. So if we have this data, if the sample mean is greater than this number or less than the other number, then we are going to be able to reject the null hypothesis that we're testing, that the population mean is different from 1000 liters at the significance level of 5%. And with these numbers in mind, we're going to see what is the probability of still being able to reject this hypothesis of this test, given that the true mean is 1100 liters. And we'll do so in the next video.